Okay, geometry, we are almost done with this book. We're on section 6 of chapter 11, volume of non-rigid transformations. So if you think back when we talked about transformations of similar polygons, we know that, like, if, let's see, maybe I should do this a little bit more exaggerated. But you know that the corresponding sides are in a ratio. So if this is 3, let's say this is 6. This is 2, this is 4. So you can see that the scale factor here is 2 to 1, right? It's going up by a factor of 2. That's when you're dealing with flat figures. But if we start dealing with solids, three-dimensional figures, it's going to be just a tiny bit different. Now, when we talk about surface area, so let's say that we had a figure like this and we had a ratio of, let's just call it A to B. Okay? But now we have a solid figure and we're going to talk about surface area. Well, when we're talking about area, you know that it's length and width. It's a two-dimensional thing. It's two factors multiplied together. So if the scale factor is A to B, surface area is going to be A times A and B times B. So it's going to be basically A squared to B squared. Okay? And likewise, if we scale this up some more and we talk about volume, well, volume is going to be a three-dimensional thing, length times width times height. So in kind of a similar way, if you have a scale factor of A to B, well, then volume is going to be A cubed to B cubed. Does that make sense? I hope so. They give you a lot of examples, and you can use this idea to solve a bunch of different problems that they give you. But that's the basics of it, okay? And I think they sum it up for you. Where do they do it at? It's theorem, this is theorem 11.1. And it just says exactly what I said. If its scale factor is A to B, then the surface areas have a ratio of A squared to B squared, and the volumes have a ratio of A cubed to B cubed. Okay? All right.